Hello, Leiden geometry students. In this assignment, we're going to talk about the area of a circle, plus its circumference and sector area and arc length. But first, what is a circle? Well, let's say this little red dot represents you, and someone tells you, hey, there's a monster and it's 10 feet away from you. But they don't tell you which direction, so you don't know if the monster's 10 feet over here, or 10 feet over here, or 10 feet over here, or maybe 10 feet this way, maybe 10 feet to the left, or right, or down, or up. If you don't know which direction it is, we have 10 feet in a whole bunch of different directions. And if we fill in 10 feet away in every single direction, what we end up doing is creating a circle. A circle is a set of all the points that are a certain distance away from another point. In other words, we start with the center, and the circle, and the center can be just any point, the circle is every point that's whatever distance, the radius, away from that point. That's what a circle is. All right, so first off, the things we're going to find in a circle. The first one is circumference. What's circumference? Well, circumference is basically perimeter. It's the distance around the outside of the circle. But we can't call it perimeter because when we talked about perimeter, we kind of described it as adding up all the sides. And the circle doesn't have any sides, so it needs a new word. And that word is circumference. Circumference is just the distance around the outside of a circle. The formula for circumference, C for circumference, equals 2 times pi times r. Okay, so r is going to be our radius in any given problem. Pi is this weird number we're going to talk about a little bit more in a minute, but for right now we're just going to use 3.14. That should be vaguely familiar to you. So if we have a problem like this, where we have a circle, it's got a radius of 6, and we're asked to find its circumference, all we got to do is we're going to plug in 3.14 for the pi symbol, and the radius, 6, is going to be coming from the distance from the center to the edge of the circle. And once you have your formula down, all you got to do is type the whole thing in the calculator. It's all simple calculations. So this is something that you just do in the calculator. And if you do it properly, we end up with 37.68 inches for the distance around this circle. Now, we can make this problem harder. There are two ways. One of them is not really a big deal at all, and actually neither is the other one. But how can I make this problem a little bit tougher? Well, instead of giving you the radius, I'm going to give you the diameter. Let's say if you look at the circle, now we got the distance all the way across, and maybe it says the diameter is 12 inches. Well, the diameter, the distance all the way across the circle through the center, is always just twice the radius. So if you're ever given the diameter, all you got to do is just take half of it, and then you do the problem normally. Okay, now here's the weird one. It's not hard, but it is weird. It's what's an exact answer? Okay, so here's the circle. We're going to find the circumference, but we need to give an exact answer. What do I mean by exact answer? Well, it has to do with pi. See, pi is this number that goes on forever. You can see it in the background there, 3.14159.265.358.979, blah, blah, blah. I'm not going to read the whole thing. But it's this number, and it never ends. It goes on forever. It never repeats. And so if we want to use pi, and we have to when we're talking about circles, we have to round it off at some point. So what do we round it to? Should we just round it off to 3, or the common 3.14, or a longer version of this thing? Actually, a common thing people used a long time ago was 22/7. It's a decent approximation of pi. But we can't use pi unless we round this number off. So because we're doing a little bit of rounding, our answer's never really exactly right. It can be really, really close, but we're never exactly right. And the way we get around this to give an exact answer is we just don't multiply by pi. We treat pi like x, and we're going to leave it in the answer. So in this problem, what we're going to do for our answer here is we're going to leave that pi there just like we would leave an x in our problem. And in this case, we're going to plug in 6 for the radius. So we're going to do 2 times pi times 6, except we're not going to multiply by pi. We're just going to do 2 times 6, which is 12. So we have 12 times pi, and we stop there. That is the exact answer. We just take one fewer step and not multiply by 3.14. And again, this is considered the exact answer because we have not rounded anything. We leave it like this. So here would be a sample problem. We have a circle. We're asked to find the circumference. We're going to be asked to find both the exact and the approximate answer. No problem. We're going to do one on the way to getting the other. All we have to do here is 2 times pi times r. We're going to plug in 8 for the radius. So it's 2 times pi times 8. Let's just multiply the normal numbers first, 2 times 8, and then we have that times pi for our exact answer. And that's 16 pi. Technically, we should have 16 pi square meters. And then if we want the approximate answer, we actually just multiply by 3.14. So it's 16 times 3.14, which will give us 50.24. So our exact answer is 16 pi, and our approximate answer is 50.24. So you can always just stop one step short to get your exact answer. Next, we're going to talk about area. And area for circles is the same as area for everything else. It's just how many little squares fit inside this circle. And we have formulas for area, and they're basically the same idea as all of our other formulas. It's what does it take to turn our shape into a rectangle? And basically with a circle is we cut it up into a bunch of slices, separate them, and then bring them down and make a rectangle with it. See, by doing it this way, by making a rectangle, we have the height of our parallelogram, actually in this case, the height is the radius, and the length of the base is half that circumference. So half of 2 pi r, or just pi r, times the height, which is r. So it's pi r times r again, or pi r squared. It may not look very good, like this is a great rectangle, but the idea here is you take more and more slices, and the more slices you take, the closer this thing is going to look to a rectangle. Now, you don't really have to be able to reproduce this. You just got to be able to use the formula that it creates. And there's another way to visualize this where we have a circle with the radius r and the circumference 2 pi r. We can unfold it into a triangle here. And the height of this triangle is the radius, and the length of the base is 2 pi r. So if we do half of the base, half of 2 pi r times r, we end up getting pi r squared this way as well. But you, again, don't have to do it that way. You can just use this formula. So this formula is pretty simple. We still have 3.14 for pi, or don't use that if we want an exact answer. And we're going to plug in 6 for the radius here. So our radius is going to be the 6. We just plug it into our formula. And now we have pi times 6 squared. So we're going to take care of 6 squared first. 6 squared is 36. So our exact answer is 36 pi. If we want the approximate answer, we're going to actually multiply that out by 3.14. So if we multiply it out by 3.14, we get 113.04 for our approximate answer. So here's a sample problem, what you might have to do. We're going to find the area of the circle. We want both the exact answer and the approximate answer. Okay, for both of them, you do the same thing. We're going to plug in 8 for the radius, and 8 squared is going to be 64. So 64 pi meters squared, that's our exact answer. If we multiply it out by 3.14, we're going to get 200.96 square meters, and that is our approximate answer. All right, next we're going to talk about a cool sounding word called sector, and it has to do with a pizza, basically. So the area of the pizza is how many bites of pizza you'd get, and the circumference is how long the crust is. Like if you're getting a special crust, like a bacon-wrapped crust, how many inches of bacon do you need to wrap around the circle? Well, let's say we're going to change the problem a little bit, and instead of asking for the whole circle, we are going to ask for a part of it. But if we start off the whole thing, when you order pizza, they always give you the measurement is the diameter of the circle. So if this is a 10-inch pizza, that means the diameter is 10 inches. The first thing we need to know is what's the radius? And the radius is just going to be 5 inches, half of that. All right, if we want to find the area of the whole pizza, we just plug this into our formula. We're going to get 78.5 square inches. We're going to use approximate answers for the rest of this assignment here. And if we wanted to find the circumference, we plug that into our formula. And we're going to get 31.4 inches. But the trick here is going to be, what if we only want half the pizza? Well, if we only want half the pizza, if we already found the area and circumference of the whole pizza, all we'd have to do is take half of it, because this is half of that amount. So if we wanted half of the area, we find the area of the whole thing and take half. If we wanted the circumference of half, we find the circumference of the whole thing and take half. What about 1/4 of this? What would be the area of this slice of pizza? What would be the part of the circumference for this slice of pizza? Well, that's what a sector is. A sector is the math term for the word slice. A sector is the official name for a slice of pizza. As long as the pizza is cut through the center, that's what a sector is. It's a slice. And what we're going to have to do is find both the area of our slice and the part of the circumference of our slice. We call these sector area and arc length. So now we just want the sector area of this slice. Well, we do it the same way we would do the area of the whole circle. We're going to use our formula, pi r squared, and we get our radius here, 7 inches. But here's what we're going to do. We're going to take pi r squared, and we're going to figure out what fraction of the pizza this is. Well, our pizza's cut up into 8 even slices, so whatever we get for the whole area, we're going to take 1/8 of it. So we're going to plug in 7 for the radius, 7 squared times pi, get some big number, and then take 1/8 of it. Find the area of this one sector of the pizza. Okay, we plug in 7. into our area formula, make sure we multiply the whole thing by 1/8 at the end, and we get 19.23 square inches. That's it. That's the area of this one slice of pizza. We find the area of the whole thing, our area formula, and multiply it by the fraction of the circle or pizza that we wanted. Same thing's true for the part of the circumference. If I want to know what's the circumference of this sector, or the part of the circumference that belongs to this sector, all right, that's a clumsy sentence. So the first thing we're going to do is shorten that to a single word. We call this arc length. That's the part of the circumference for us, one sector of a circle. Or in other words, how long is the crust on this slice of pizza? Well, we do it the same way we do circumference. We take our formula for circumference. We're going to plug in 7 for our radius, but then at the end, we're going to take 1/8 of it. Why? Because there's 8 slices, and we only are looking at one of them. So we take 2 pi r and then multiply by 1/8. All right, so 2 times pi times 7 and times 1/8. Crunch all that in the calculator. We should get 5.495, or about 5.5 bites for that one slice of pizza. So now we're going to take out the rest of the pizza and just focus on a single slice or sector. And in this case, now we can't even tell how many slices are in it, but we're given the measure of the angle that makes the slice. And that's all we need to do this. If I want to find the area of this sector, of this slice of pizza, what we're going to do is we're going to take the area of the whole circle. We can find that because we know the radius here. And we want 40 degrees of it. Now remember, it's 40 degrees out of 360. So the area of the whole circle here is pi r squared. But we're going to multiply that by the fraction of the circle that we have. And what we have is 40 degrees out of 360 degrees. So we multiply by that fraction. So in our formula here, we're going to take this and multiply by our angle over 360. It's kind of a scary looking formula, but all it is this is the area formula out front times whatever angle we care about, in this case 40 degrees, out of 360, which is the whole pizza. So this is our formula for finding sector area. So if we're actually going to find the area, we're just going to use this formula. We're going to plug our information in. 6 goes in for the radius, and the 40 goes in for our angle. And then the rest of this is just a calculator problem. It looks like this. Pi, we'll use 3.14, times 6 squared times 40 divided by 360. If you do that properly, you get 12.56. Next, we're doing the same thing. What about finding the arc length? Okay, arc length has basically the same idea here. We're going to take the circumference of the whole pizza, but we only want 40 out of 360 degrees. So we're going to multiply by 40 over 360. So again, we have this big ugly formula, but all we got to do is plug in the radius for r and our angle for this theta symbol, and it becomes 2 times pi times 6 times 40 over 360. If you do that right, you get 4.19 inches. All right, so practice problem. Here's the formula. Here's a picture. Find the area of the shaded sector. Okay, if we do it right, we plug in 6 for our radius, we plug in 60 for our angle, and the rest of it's just calculator work. We should end up with 18.84 square inches. And then our last problem, doing the same thing, circumference, but we don't want the whole circumference, we just want this arc length. No problem. Here's our formula, 2 times pi times r times our angle over 360. We're going to plug in 6 for the radius, and again, 60 for the angle. And once you've got that, the rest of the work is done in your calculator. We end up with 6.28 inches.